and welcome, and in this video we're going to be talking about factor by grouping. Now, we already talked about this a little bit when we factored quadratic trinomials, but I do want to take a look at a couple of more problems and how we can now factor a little bit further in certain instances using some of those methods we have already talked about. So we generally factor by grouping when we are giving something like this. We factor by grouping, and we can only factor by grouping in special instances. It might not always work, but we try factor by grouping whenever we have generally 4 terms. If we have 4 terms or 6 terms or 8 terms, we generally try to factor by grouping. It might not always work, but we try it. Now, remember, factor by grouping comes from us grouping, in 4 terms cases, the first 2 terms together and the last 2 terms together. And then we take out the greatest common factor in each group. So if I look at this first group here between 4x cubed and 3x squared, I can take out an x squared. And when I take out an x squared, that leaves me with x squared times 4x plus 3. If I look at the second group between negative 44x and negative 33, I can factor out a negative 11. Now, I would want to factor out a negative 11 because the first term is negative. If the first term was positive, I would factor out a positive. Now, I am factoring out a negative 11, so when I factor out a negative 11, that leaves me with 4x plus 3 inside the parentheses. And as we can see, we have 4x plus 3 here, we have 4x plus 3 here. That means it's factorable by grouping. If we don't get the same binomial factor, it is not factorable by grouping, or you might have just made a mistake. But it's not always going to work. But here it does. So what this means is I can now take out the greatest common factor of 4x plus 3. So I can factor out a 4x plus 3, and that leaves me with 4x plus 3 times x squared minus 11. And here, we might actually be able to factor further. That x squared minus 11 could be broken down further using difference of squares if everything's a perfect square and a subtraction. Maybe there's a greatest common factor I didn't look for first. Remember, that always should be your first step. But in this problem, there was no greatest common factor. 11 is not a perfect square, so I actually cannot go any further. So this would actually end up being our final answer. That's factor by grouping. It's really not that bad. As long as you know how to take out a greatest common factor, you pretty much know how to factor by grouping. Now, I do want to take a look at 2 more problems, ones that become a little bit more challenging. So let's go ahead and take a look at another problem. So say we had this problem here, 16x cubed plus 64x squared minus 9x minus 36. Now remember, the first thing we should always look for is a greatest common factor. In this problem, we do not have one. So I go straight to factor by grouping. So I can group my first 2 terms together and last 2 terms together, and you generally want it to be in standard form. Remember, descending order, highest exponent to lowest exponent. You also can use this when you have multiple variables. Don't think it has to be a single variable thing. It also works with multiple variables in specific instances, just like normal. Now in this first group, I can actually take out a 16x squared. So when I factor out a 16x squared, that leaves me with 16x squared times x plus 4. And in the second group, once again, I'm leading with a negative number, so I'm going to factor out a negative number. And between negative 9x and negative 36, I can factor out a negative 9. So I factor out negative 9, and that leaves me, once again, x plus 4. Now remember, that's how I know we can actually factor by grouping. If we have the same binomial factor, that means we can factor by grouping. Because now I can take out that factor. X plus 4 is the greatest common factor, the same way 16x squared was the greatest common factor. So I can actually factor out that greatest common factor of x plus 4, and that leaves me with x plus 4 times 16x squared minus 9. However, remember, you always need to see if you can factor further. And in this problem, we actually can factor further. 16x squared minus 9 could be factored by using difference of squares, because 16x squared is a perfect square, 9 is a perfect square, and they are both subtracting. So I can actually break this down further to x plus 4. And remember, when we use difference of squares, that's 2 binomials. One's going to be addition, one is going to be subtraction. And that's going to be 4x plus 3 and 4x minus 3. And that would be our final answer. So we're always going to want to factor completely. So that's another case of factor by grouping. Let's take a look at one more problem. Okay, let's take a look at this last one. We have 2x cubed minus 4x squared plus 32x minus 64. First thing you should always look for is greatest common factor, and there is one. I can factor out a 2. All these numbers are even. So I can factor out a 2. So I'm factoring out a 2, and that's going to leave me with 2 times x cubed minus 2x squared plus 16x minus 32. And now I can factor by grouping inside. So this is going to get a little bit messy. You could wait to factor out the greatest common factor at the end, but that means you always have to check out all of your factors at the very end to see if there's any greatest common factor. I prefer to get it out of the way in the beginning. You can feel free to wait until the end. You would get the same answer, it just might be a little bit more complicated to get there. But now we can factor by grouping, so I'm going to go ahead and group my first two terms here and my last two terms here, and I'm going to factor by grouping. So this 2 is just going to stay out in front, and we can factor out in our first group here an x squared. So when I factor out an x squared, that leaves me with x squared times x minus 2. And in the second group here, I can factor out a 16, a positive 16. And that leaves me with x minus 2. And as we can see, we have a common binomial factor. We have a greatest common factor of x minus 2. So I can factor out that x minus 2, and that leaves me with x squared plus 16. And this is when we need to double check our final answer. Now remember, if you didn't take out a greatest common factor in the beginning, one of your two factors would have a common factor too, so factor it out, okay? Also, I have x squared plus 16. I can't factor that further in the real number system. Technically, you could factor that using imaginary numbers. I'm not going to be covering that here. If you're interested, please just let me know. But we cannot factor that any further. It's called difference of squares, not sum of squares. So if that was x squared minus 16, we'd be able to go a step further. But since it's plus 16, we actually cannot, and we need to stop here. And this would be our final answer. And that is factor by grouping. We're going to cover a couple more different types of factoring. So there is something called sum and difference of cubes. So we have covered difference of squares, but we haven't covered the sum or difference of cubes just yet. So make sure you watch that. We are also going to be covering factoring different types of trinomials. We have covered quadratic trinomials, but you can use the exact same idea for special trinomials. They follow a particular pattern. Generally, you see it with quartics, but you could also use it with higher level polynomials as well. So I will be making a video on that. So if you have any questions, please feel free to let me know. Otherwise, I look forward to seeing you all in the next video.